see this from the back row, you guys? Make my text big. Okay. You might have heard lately something called a supermoon. Yeah, it's mostly just BS, okay? So watch this. Supermoon is a full moon, all right? So the moon's orbit around the Earth is elliptical. Sometimes it's closer, sometimes it's farther. That's what elliptical means. And occasionally, you combine full moon with when the moon is closer to us. And somebody decided to call that a supermoon. Now here's what gets me. Here's an article from space.com. The headline is, Supermoon in December 2016. When, where, and how to see it. It's a full moon, people. What is going on? Okay? Then you get things like this. Supermoon, right? Biggest full moon in 18 years. And they don't tell you how much bigger it is than other full moons. They just say it's the biggest. And we like having all these superlatives. The biggest, the smallest, the this and the that. And that statement is not fundamentally different from me doing this, okay? I've never been this close to China before. Yeah, it could be true, but it's not interesting, okay? Let's take a look at the size of, I can point this way and everybody sees it, there we go. Let's take a look at the size of the December full moon, which was called a supermoon, and compare it to the January 2017 full moon. Here we go, ready? So, there it is. There it is. Supermoon on the right, the full moon 1 month later on the left. And I happen to like pizza, so I compare them to pizza. All right, here we go. The moon at its smallest we could be a 7-inch pizza on average, 7.5-inch pizza, a large moon, 8-inch pizza, a super moon, 8.05-inch pizza, okay? So for me, I reserve the word super for things that genuinely have earned it, like Superman, Super Mario Brothers, or something where super matters, all right? Not this. How about math? All right, so some of these charts you're not going to be able to see from the back row, but I'll make it clear what they are. So this is a chart where you do not want to be at the top. The country struggling the most with math. Percentage of 18 to 29-year-olds with low numeracy skills in developed countries. So the United States is at the top of this list. 29% have low numeracy skills. And it goes lower and lower and lower, and you get to Japan and South Korea at the bottom. Those are the countries that will lead the world in anything that involves math, which is basically everything. Because you can't see that in the back row, there you go. You got that now? So now, things that I worry about, so the consequences of this. So I have an odd habit where I photograph elevator buttons. I'm self-aware of the habit, so we're halfway there to solving it. But just take a look at this. 4, 5, 6, 7, 8, 9, 10, 11, 12, 14. It's even true for the hotels in this area. 14. So I like taking a Sharpie, crossing out the 14, saying that's the 13th floor, you're not fooling anybody. And what worries me is that in this, the 21st century of the United States of America, we have people walking among us afraid of the number 13. Now we live in a free country. You'll be able to think whatever you want, be afraid of whatever you want. But it seems to me, if you're afraid of the number 13, you should not be tasked with designing elevator number banks, okay? There are other jobs for you. This is what I'm thinking. And then you go below ground level, okay? So you go below, so I don't have it in the photo. So 3, 2, 1, what comes below that? Like L, LL, B, SB. First, I need a vowel to know. So can I buy a vowel, please? Find out where you're going there. Now, we know we have a perfectly legitimate arithmetic solution to that problem, okay? 0 and then negative numbers, okay? But we fear them. And I don't know who to blame. Maybe the accountants? Do accountants ever use a negative sign? I don't think so. They tend to use parentheses. Why? Now, if I ask you what country is best known for its engineering, what would you say? Germany. Germany. And justifiably, there could be other countries good at engineering, but Germany, it's a selling point, and I think it's an earned point. Okay? So it's in the culture. Deep in the culture. They make good stuff. All right? So you go to Germany, this is a photo, and you go below ground level, and the floor is -1. There you go. By the way, wait. Is this the German Science Museum? Is it the German Math Museum? No, it's the German History Museum. Right there. See that? So then I thought, is it in the water supply in Germany? What is it? And then I found in my collection a 10 Deutschmark note, pre-Euro. And it has Carl Friedrich Gauss on the dot. So this is like a scientist, a polymath. And I'm thinking, wow, I remembered Europe loves their scientists. They used to put them on their currency. And then I look closer at this note and I said, what is this? Oh my God! There's a mathematical distribution function on your currency. So if you're German, even if you don't know that this is the famous bell curve, it's unmistakably math, and you know it's important because it's on your currency, and that dude must be an important mathematician, so you are sensitized to the importance and value of science and math. It's in the culture. So that the least of their problems is putting a -1 on a floor below ground. So the culture of discovery, the culture of science, is something that I think is not everywhere, and it should not be taken for granted when you have it. Then I thought, wouldn't it be cool if we had, in this country, if we did that, you could just be real. So watch this, we can do this, watch it, I think. That it? Yes! Okay. How's that for an obscure equation? This equation is so profound that e to the I pi equals -1, therefore God exists. Have you ever seen that proof? It's an equation invented by Euler. But anyway, there's also bad physics out there. So this happened a few years ago. Hotel chain, they're talking about Holiday Inn, offers human bed warmers. Human bed warmers help guests get a good night's sleep. And so, like, what could that mean? Right? So, do you want somebody else in your bed who you don't know? So somebody did not fully understand thermodynamics, because if somebody else is in my bed, I don't want their skin touching anything. And they knew this, so here is their ad photo. Okay? So he's looking at her, she's looking at him, he's looking at him. There's an interesting little triangle there. But my point is, they are so insulated, they can't possibly heat the bed. You see what I'm saying? Look, the fans there. So somebody did not know physics, and they're taking out ads and trying to make policy. So it gets me angry. This is going on out there. But let's go happy news, okay? Let's do happy news. Who here, just make a noise, I can't see your hands. Who here doesn't know anything about me at all? Just raise your hand. That's okay. In the front row, okay. Why are you in the front row? Okay? Because this next slide is kind of funny, but you have to know me to know that it's funny. Okay? So here it is. Okay? So So I'm, I just want to remind you, it's still not a planet, okay? Do anybody have issues with that? Oh, no, some of you have issues with it. Okay, so just get over it. We're long past. For the Pluto lovers out there, you probably didn't know that, for example, our moon is 5 times the mass of Pluto. They didn't tell you that, did you? A little bit of information like that has you understand why Pluto got demoted. We got good pictures of it. The New Horizons mission went to Pluto. This is one of the images before it got real close, so you get the full ball there. This next image, I warn you, you cannot unsee. So avert your eyes now if you are one of these people that cannot unsee things. You ready? Here it is. Here. Okay? There. Yeah. You know, I work at the American Museum of Natural History in New York City. So I work in the universe part, but there's zoologists of all stripes working in the rest of the museum, entomologists and paleontologists and mammalogists. And so some of that rubs off on me osmotically. And so I had deep concern when I was thinking about Pluto. How is it that a mouse can own a dog? That's just wrong. So I went to Disney and found out how is it that Mickey can own Pluto? And they explained it to me. They said, in the Disney pantheon, if you do not wear clothes, you can be owned by another animal who does. And Pluto is butt naked, walks on all fours, lives in a doghouse, and barks. Whereas Goofy wears clothes. He walks bipedally, lives in a home, pays mortgage, has kids, drives a car. That is the last thing you probably thought you would learn at this conference. Okay. Well, the New Horizons mission has already flown by Pluto, so just so you know, NASA announced 6 months ago that it will continue on. It'll be guided to another destination, because it couldn't slow down and park in orbit around Pluto. It was going too fast, because it had to get there before all the principal scientists died, which is one of the first rules of your experiment. You should finish it before you die. So it got out there in 10 years when it might have otherwise taken 20. So there's another object, KBO, Kuiper Belt object, MU69. It's unnamed yet. That's a sort of provisional discovery name. So just watch that. So there'll be more things to discover in the outer solar system. We're talking about planets. There's evidence that there might be another planet orbiting well beyond Pluto. Excuse me, a planet, not another planet. Pluto, there's only 8 planets right now. So you might have heard this, they call this Planet 9. And these are 2 colleagues of mine from Caltech. We've got Mike Brown, who, by the way, is probably most responsible for killing Pluto. I get a lot of blame for it, because we were the first public institution that reclassified Pluto into a different place in our exhibitry, and the New York Times wrote about it. The Pluto not a planet? Only in New York. That was their headline, right? And then I got hate mail from school children, and so I got blamed for this, but I was an accessory. He did it. In fact, his Twitter handle is called Pluto Killer. That's his Twitter, so he admits it. Okay, so killing Pluto was fun, but this is head and shoulders above everything else. What they did was, they found objects orbiting in the outer solar system that were not behaving according to traditional Newtonian gravity. Something was influencing them. So either Newton is wrong, that's not where you should be betting in this example, or there's some other source of gravity yet to be tabulated whose influence on these objects is causing this perturbation. And so they did it's a difficult calculation, by the way. It's an inverse. It's not here's gravity, what effect does it have? You're now asking, here's the effect of gravity, where is the object who is causing it? That's an inversion problem in the math, and it's very challenging to get that right, but I've seen their calculations, I'm convinced. So they have inferred the presence of a planet 9, and now they're looking for it. Now, don't think it's just, oh, now there are 9 planets, not Pluto. This thing takes 20,000 years to go around the sun. So I'm not calling it part of our family. It belongs to somebody else, some other family. I'm not. Now, we've been looking for planets outside of the solar system. We just discovered the best exoplanet ever. The European Southern Observatory discovers an Earth-sized planet orbiting the habitable zone of the closest star to the sun. You can't get better than that. What more do you want in the universe, right? So this planet, that's an artist's conception of the planet. Clearly, we haven't been there yet. And it's called Proxima b. The Alpha Centauri system is the closest star system to the sun. There are 3 stars, at least 3 stars in that system. The nearest one is Proxima Centauri, and that's the star that has an Earth-like planet in the habitable zone. Habitable zone is like, but also you might think of it as the Goldilocks zone. You want to be too close to the star, your water, if you have it, will evaporate. Too far away, you freeze. Right in the middle, you're just right. And everything we know about life on Earth requires liquid water. So it's an understandable bias as we look to other planets, to look for planets in the habitable zone of their host star. Now that we know about this, it's a destination. So there's the breakthrough projects. One of them is called Starshot. And this is the billionaire Yuri Milner. He's an internet investor. And last year, he said, you see what he's holding in his hand? Like an almost postage stamp sized chip. It's not quite ready for this experiment, but what he wants to do is further miniaturize that, have it contain telemetry, photography, other data-taking properties, and then attach it to a solar sail. Just a sail, because we're not going to use the sun for this, you'll see in a moment. And if you do that, and you beam lasers at this sail, then the light pressure will accelerate it, and if you do it right, with enough power, you can accelerate it to 20% the speed of light. And if you do that, and aim it towards Proxima Centauri, which is 4 light years away, 20% the speed of light, you do the math, carry the 2, it'll take you 20 years to get there. 20 years to get there. 1/5 the speed of light times 4 light years, 20 years. That's kind of doable thing. But then it sends data back. That's another, then that's only 4 years. The data comes back at the speed of light. So it's a 24-year round trip. And here's how they're going to do it. This actually looks really, really dangerous. So notice it's like over the cliff ledge, so you can't see it. Here's just a deployed, so the chip is in the center of that mylar sail. So the sail doesn't weigh very much at all. So here they go. Yep, see, that's how, I told you. So and there they go, off to the races. So this is a very, very light, and they would put 1,000 of them out there. They expect some losses trying to navigate, well, they won't navigate, they expect some losses trying to get through the asteroid belt and other possible failures. But some of them would then make it all the way to Proxima Centauri. That's the goal. It's a breakthrough project, which is a suite of on the frontier sort of things that we don't know how to do yet. Let the goal guide your ingenuity to make it happen. As most great discoveries, especially technological discoveries, unfold. Far, far away, 1.3 billion years ago, 2 black holes collided. One of them had a mass of 29 times that of the sun, the other 36 times the mass of the sun. And when they collided in that instant, they released 50 times the total power of the entire universe in that instant. This is a stupendous fact. That is the merging of 2 black holes. And when that happens, it actually sends out waves, gravitational waves, emanating from that spot at the speed of light. And they've been traveling ever since. Well, what was Earth doing 1.3 billion years ago? Earth was inventing sex, okay? Now, this is a very modern sex image, but the early eukaryotes were, that was the dawn of sex on Earth 1.3 billion years ago. Let's fast forward to 500 million years ago, the Cambrian explosion of life. So we have organisms where we have differentiated limbs for the first time. Eyes, locomotion with appendages. So life got very interesting 500 million years ago. 65 million years ago, we lose the dinosaurs to an asteroid impact. Mammals do not yet have much of a presence on Earth. You'd have to wait many more million years before they would rise. Because until then, we are hors d'oeuvres for T-Rex running underfoot. 3 million years ago, the earliest evidence of hominids. Lucy, it would be in this group, the Australopithecines. That's 3 million years ago. 50,000 years ago, that gravity wave reached our galaxy. After crossing intergalactic space, the gravity wave began, is my attempt to demonstrate that, began to wash across our galaxy. Of course, that's not our galaxy because we're in our galaxy. That's a picture of a galaxy that looks a lot like ours. So it starts coming in 50,000 years ago. 40,000 years, we have anatomically modern humans. I'm betting their skin wasn't that white because we were still coming out of Africa. That's how that goes. So, 20,000 years ago, we domesticate dogs. We demonstrate the first sort of cultural offerings in the form of our art. 5,000 years ago, we built the pyramids. Pyramids, stunning architecture. We did not build stable structures taller than pyramids until the Eiffel Tower. That's how innovative those were. Go back 2,600 years, Buddha. Okay? That gravity wave is still moving through our galaxy. And life on Earth managed to have a branch of itself that had big brains that actually think about its own existence and think about the world around it. Civilizations unfold. So Buddha, 2,600 years ago. Jesus, 2,000 years ago. Muhammad, 1,400 years ago. This keeps going. We have the Industrial Revolution. We have the Renaissance, not in that order. We have 1879, Albert Einstein is born. He's a little older in that picture than the moment he was born. What happens when he turns 26? He writes down E = mc squared and invents the special theory of relativity. 10 years later, at age 37, he invents the founding equations for the general theory of relativity, which is the structure, the fabric of space and time itself. This is our entire understanding of Big Bang cosmology. It derives from this. Also in 1916, he wrote down the equation for the stimulated emission of radiation. This is the theoretical foundation for the laser. Einstein did this. The laser. There wasn't a phrase back then. It would later be invented as a physical object, but that is the theoretical substance for what made that happen. Also in 1916, he predicts the existence of gravity waves. He predicts it. 1921, he wins the Nobel Prize in physics. Not even for relativity, for other stuff he did. If you tally his actual output and wanted to give he'd have 7 Nobel Prizes. 1921, 1955, he dies. Okay, now what? Oh, and also we saved his brain. Okay, left first. They cremated him, kept his brain. What happens? 2 years later, the laser is invented based on his formula for how you have stimulated emission. And what happens in the 1960s? We perfect the physics of black holes. So now we have lasers and black holes, well understood long after Einstein, when he laid down the foundation for it. Okay? Now, where's the black hole? It'll manifest itself immediately, right? There it is, okay? So black holes become visible when they eat something else. Okay, that's how that works. What happens? Somebody wants to detect gravity waves of colliding black holes. So the Laser Interferometric Gravity Wave Observatory is proposed to the National Science Foundation. They fund it. But the technology isn't good enough yet. But we know what we have to do. What we have to do is we want to check what happens when a gravity wave washes over where you are. So you'll have two path lengths, and you want to see what their lengths are relative to one another as the wave passes across. This is an interferometer, and it is a brilliant way to measure very small changes. That's a wavelength of light coming from a laser that then comes back, recombines with itself, comes out the right side, and if any of those path lengths change, the phasing changes, and you can measure the difference in the phase. There. They line up or they don't. And that is a critical measure of how accurate you can determine how much a path length has changed. They finally get the next generation, it's advanced. To collect colliding black holes, they have to measure a shear to 10 to the minus 21. Oh my gosh. What? Let me skip that and let me show you what that is. This is an atom. Let's zoom in. Okay? Zoom in by factors of 10. This is factor of 10. Another 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 factor of 10. Now, that is the edge of the nucleus of an atom. And that is the difference in length that we are measuring when we detect the presence of gravity waves coming across. And so, there are two observatories. I got 4 slides left. There are 2 observatories, Livingston in Louisiana and Hanford in Washington State. The others were being built when these data were taken. So you want 2 measurements, not just one, because it could just be a fluke. So sure enough, they did exactly that. And they were looking, they turned on the machine. They each measured this signal. And this is what was happening 1.3 billion years after. This is a series of gravity waves coming across Earth. And as the black hole spiral, it gets more and more intense and more energetic. Then the black holes, boom, now it's one black hole. Now, that was highly exaggerated. I don't want you worried. So I just want to say, after all of this, Einstein was a badass, okay? He discovers general relativity, invents the premise for the laser. Years later, we invent the laser. We develop black holes. We create the machine that measures the gravity wave that was born before we were even a species. You want to talk about breakthrough. That's a breakthrough. And here's more breakthrough. You ready? We've got fashion. There's someone named Holly Renee who designs clothing that has scientific themes to it. This is the LIGO dress. All right, and it's not just that. Geeky dresses. This one is Saturn's rings. Got the periodic table of elements. Got the Fibonacci series. We got Jupiter. We got DNA. We got a wormhole. And we got a Mars costume. Ladies and gentlemen, thank you for your attention.